Hello students, today we are going to see some more interesting and important questions from MS Chouhan's Organic Chemistry, Isomerism and level 1 and the question from 191 to 200. Come on, let us discuss. A pair of stereoisomers might be classified in various ways. Which of the following statements are true with respect to pairs of stereoisomers? Okay, now they are asking in this question stereoisomers only. So, what are that isomer divided into two groups, and those points let us check so that you will come to know the very clear idea. So in the option, whatever points they have given, first let us check, then we'll go for the answer. Okay, now they might be configurational isomer, they might be diastereomers, they might be constitutional isomers, they might be tautomers, they might be conformational isomers, they might be enantiomers, and they might be positional isomers. Yes, come on, let us check here. I brought those two pictures so that you will get the complete idea about that. So isomers divided into two main things, that is constitutional isomers, that is a structural isomers, and stereo isomers, that is a spatial isomers. So the spatial isomers here, they in this picture they have given. So in this point, diastereomers have divided into two categories, that is cis and trans isomers, conformers and rotomers, whereas here enantiomers. Now here in this point, very clearly you will get that idea. So isomers, that is a constitutional isomers, configurational isomers. So constitutional isomers is nothing, structural isomers. Structural isomers divided into 5 points, that is chain isomer, position isomer, functional isomer, metamerism, tautomerism. All this comes under structural isomers. Structural isomers also known as constitutional isomers. I hope you got the clarity. The second one, stereo isomers. Stereo isomers, it is nothing, conformational isomers. So conformational isomer, configurational and conformational. Okay, now here in this point we may say constitutional isomers and conformational isomer. So here stereo isomers only. So in that stereo isomers, configurational isomers, conformational isomer. Configurational isomer divided into two categories, that is geometrical and optical. After that, I think you might got that idea about how do we identify geometrical isomers, how do we identify optical isomers. You might have seen so many ideas through all these videos. So from this, which is the correct option? Come on, let us check. So here the first one, they might be configurational isomer. They are asking about that stereo isomers only. So the stereo isomers, it is actually here in that stereo isomers only they are asking. So stereo isomers, configurational isomers, yes, it is there. Configurational stereo isomers only. No, so stereo isomers, configurational isomers is available. And they might have diastereomers. Diastereomers, stereo isomers only, diastereomers is there. Yes, this also it's correct. They might be constitutional isomer. Constitutional isomer, it is a structural isomers. This will not come under stereo isomer. I hope you got the clarity through these pictures. Yes. Now they might be tautomers. Tautomers also comes under constitutional isomer. See here we have gone through, no, tautomers also comes under structural isomers. Structural isomers also known as constitutional isomers, right? And the next one, they might be conformational isomer. Yes, they are conformational isomers only. Yes, it is correct. And they might be enantiomers. Enantiomers also it is correct. Yes, it is correct. And they might be positional isomer. Positional isomer comes under structural isomers, which is also known as constitutional isomer. So this will not be the correct option. So which are all correct option? A, E, B and F. So A, E, B and F. So A and B. E is not there. So A, B, F it is there. So option C, A, B, F. Actually E also it is correct in this point. If they mention E, that is also correct. And A, B, C, F, no, this will not be correct. And B, D, D where it is D. So the tautomers will not be coming under this. And A, B, C, C will not be coming. So the option it is A, B, F. F, which is F, yeah, enantiomers is coming under stereo isomers. I hope you got the clarity all these pictures. Okay, come on, let's go to the next question. The next question, ignoring specific marking, which of the following objects are chiral? Right now, they have given that wordings: a shoe, a book, a pencil, a pair of shoes, considered a pair of as one object. Right now, a pair of scissors. Right. Okay. Now, in that, I have given the picture also for you to identify. So, how do we identify the chiral? So, they are asking about chiral. Chiral means four different groups or atoms attached to that carbon, that is called chiral carbon. You might have seen very well. So, here they have given that specimen to identify chiral. So, four corners, it has to be different. That's all. Okay. Now, you are taking a shoe. So, in that shoe, here, so this is a center. So, this part, it is totally different. This part, it is totally different. This side also, that side will not be same as this side. So all are different. So this is 100% chiral. I hope you got the clarity. And the same way, book it is actually symmetrical. Symmetrical means it is like a chiral. So achiral. So these both the corners are same. The same way this both the corners are same. This both the corners are same. So this side here. So this is achiral, but here all the corners are different. Even pencil also. Pencil actually when you draw a line in between, you are getting a symmetrical. Both the sides are same only meso compound like achiral. This also achiral. So they are asking about chiral only. And even shoes. This side and this side both are similar only if you cut in between. So both are same side. So you will get that what it is. Same only. And the scissors. Scissors if you cut over here. This is different object. This is different object. Actually, this is a center. So here one corner. This is off circle this side. That is off circle that side. And even size also vary. So this is also chiral. So first and 5. 1, 2, 3, 4, 5. So first and 5 are chiral. So 1 and 5 are chiral. So here in this they have given the picture. See how they are asking the questions. Okay, and I just brought some more ideas for you to identify, because in JE exams a number of questions they may ask like this also, like physical way, like which is chiral, which is meso compound, which is plain polarized light. Number of ways they may ask the question. If you know the concept you can clarify that. Right now here this is actually what it is. This is both the side are same, so this is actually a chiral. And this is both the side are same, this is also a chiral. And a chiral, right? And this also like meso, it is there. No, identical, both the sides are identical. This is also a chiral, right? And this side only one hand which shows this is a central. So each hand fingers are different, right? So this is a chiral. Okay, so and this also a chiral. So both are a chiral. I hope you got the clarity. So a chiral means what? Chiral means what? What are the points applicable for a chiral? What are the points are applicable for chiral? I think you might have known thoroughly. From that only, you will get that all the ideas about enantiomers, diastereomers, optical isomers, optically active, optically inactive, plane polarized light, whether it is rotate PPL or cannot rotate PPL. So you have gone through a number of questions and then answers also in this. All those videos, whatever you observed. Yeah, come on, let's go to the next question. I hope you got the clear idea, whichever way they are asking question. Yeah, come on, let's go to the next question. As we observe here, calculate the total number of stereoisomers when alkene having trans configuration. See, here they are asking trans configuration. Okay, now first and foremost, let us check here how many stereoisomers are possible. See, first and foremost, this is actually what it is: unsymmetrical compound. Unsymmetrical compound. So unsymmetrical compound means what is the formula for unsymmetrical compound? Total number of stereoisomers. So total number of stereoisomers, what is the formula? 2 to the power of n. So n equal to what it is? Here 2. How do we identify it as 2? So this is only, so from here. So cis and trans you can identify in that way only. So here actually 4 isomers are possible. Alkene having trans configuration 4 only. So the answer it is 4. Very simple. All right, come on, let's go to the next question. Compound. Prolonged treatment with DTO and DO minus, that is H2O and OH minus, like that only. D2O, it is actually isomers, hydrogen isomers, that is actually what it is, heavy water, right? D2O, it is heavy water. Prolonged heating, what is the point you will be getting? See, here actually what it is, here keto compound is there along with the alkene. Okay, so here keto compound is there, means naturally you will have what it is, one hydrogen both the side, and this side also one hydrogen will be available, and here this side it is two hydrogen will be available. Okay, now if you are heating with the prolonged heating with what it is, D2O, right? DOD minus, right? So this is a basic medium. This is 100% what it is, basic medium. Okay, but here actually what it is, alpha hydrogen is available. So alpha hydrogen is nothing, acidic hydrogen. So naturally acidic hydrogen, as it will be converted to D. So here D is there, no? So naturally it will be changing. So how many hydrogen? Alpha hydrogen is there. Here also alpha hydrogen is there. Why I'm mentioning all this? Because here prolonged heating, prolonged heat is available, right? So if you go on heat, first and foremost you will get this structure. Why? So you'll be getting what it is here, D will be there, and here also D will be there. Right, now next one what you will get it, again here hydrogen only is available, right? And both the side hydrogen is there. But so due to that still more you are heating, no? So this also will be removed. So that means what you will get it, you will get another compound, what it is, 4 side also D will be there. So here also D, here also D, hydrogen is replaced D, that's all, right? Here also D and here also D, and here double bond O, but here hydrogen, right? So now this is prolonged heating with that same D2O, heavy water. Now they are asking about that difference in molecular weights of compound A and B. So compound, this is compound A and this is compound B. So molecular weight difference, yes, of course, 100%. Here how many hydrogens are there? Actually, okay, four hydrogen, alpha hydrogen, how many? Four hydrogen. So naturally four deuterium also will be available, hydrogen isotope deuterium also available. Now when we compare with that mass, hydrogen atomic mass of hydrogen. So mass of hydrogen 4 into 1, whereas here mass of deuterium 4 into 2. Mass of deuterium, right? So here what you will get it, here 4 only, but here what it is, 8. So how much it will be differ? 8 minus 4, you will get 4. So the mass of the deuterium compound, that is compound B, will be 4 points extra. So they are asking that question, prolonged heating with the deuterium, that means heavy water DO minus, the difference in molecular weight of the compound A and B. So this is a B. What is that B compound here? Prolonged heating. So you will be getting this one, double bond O, here D and here D, here D and here D, right? So removal of hydrogen and replacing of hydrogen, and you will get what it is. DD will be there, right? Both here down part it is hydrogen only. So what is the difference? It is actually deuterium. It is comparatively hydrogen, deuterium it is 2, tritium it is 3, hydrogen isotope, no, so atomic number 1 2 3, right? So in that way if we say, that means here how much? 4, it will be vary. So the answer it is 4. Here I think I have given the clear idea about how do we go for it. 4 hydrogen is there, 4 deuterium is there. 4 mass of hydrogen 1 means deuterium, mass of deuterium it is 2. So 4 into 2 means 8. So from that, what is the difference? 4. I hope you got a clear idea about this question. Come on, let's go to the next question. The next question here, 1, 2, 3, 4, 5, 6 hexane. Okay, so while heating with that Cl2 along with light, you will get what it is, a mixture of all isomers possible from the monochlorination of the structure is subjected to fractional distillation. Then how many fractional will be available, obtained? So here they are mentioning about all isomers. Okay, now let us check here. 1, 2, 3, 4, 5, 6 combined with the Cl2 in the presence of light, sunlight, that is H nu. Right. So you will get first one monochlorination. So if we put it like this, so if we put it like this, Cl will be there. Even if I put Cl, also the same only. There is not much difference. Right. The second isomer, because monochlorination they mentioned, right? So you will get another isomer here. That second point you will get chlorination. And the third one here, you will get another compound, you will monochlorination, you can expect this side Cl. So you will get, now if I put it this side also the same thing, you will get that another one, 1 2 3. So here 1 2 3. So if you put it here also Cl, now again one more compound if I put it also, the same position only will be getting when you count from here. So only these three compounds, they are asking about what it is, fractional distillation, and they are mentioning about isomers. Isomer only they are mentioning. Okay, they did not mention a chiral or anything else. They are asking about monochlorination. The structure is subjected to fractional distillation. How many fractions might be obtained? So this is 3. You will be getting 3 options, because one part and the second part and third part. Suppose if you start from here also, this side, this side, this side, 1 2 3, 1 2 3, all are same, right? I hope you got the clarity. Come on, let's go to the next question. Very simple and easiest question. The next question, as we observe this compound, number of optically active isomer. See, as we observe here in this point, when we cut over here, it's a symmetrical compound. Symmetrical compound means it's an achiral. Achiral, and it is POS is present. See, POS planar, it's a POS is present. POS is present means 100%. You cannot identify the optically active. See, actually, achiral means what it is? Optically inactive, right? So optically inactive. So optically inactive compound, they are asking about how many number of optically active. It is actually totally, it's a symmetrical. Symmetrical means achiral compound. Achiral means naturally POS will be there. POS is there means 100% it is optically inactive. So they are asking about the question optically, number of optically active means 0 only will be available. Right. I hope you got the clarity. What is the correct answer? Yeah, come on, let's go to the next question. Simple, basic idea. If you know the concept thoroughly, if you have the key, you can open any of the lock according to that key. at normal temperature x and y, resonance structure, tautomers, functional isomers, positional isomers. Okay, functional isomers, positional isomers will not be possible here, because here functional isomer, here OH is there, here O it's there. So functional isomer, same molecular formula, different functional points should be there, but here extra hydrogen is there, so this will not be the correct. Positional isomer also, here what it is, OH, maybe here and there somewhere changes, that means we can identify positional isomer. So positional isomers also, which is not possible. So, and resonance structure also, it is what it is, delocalization of electrons as transfer of electrons, that is also not possible. Here tautomers only is the correct option. How come tautomers are possible means, now see, for example, here C double bond O, here C double bond O here. So in this point here, two hydrogen is available, so that means this is alpha hydrogen, and this side also you are having alpha hydrogen. So here one alpha hydrogen. So that means when it is converted over here, the transfer of electrons, so this hydrogen which is going to attach, and the same way when it is a transfer of electrons, so this hydrogen which is going to attach. So that is what OH, here OH has changed. So naturally you will be getting what it is, hydroxyl group. So keto group, keto group is there means naturally you will get that next to point enol when they are having normal temperature, right? So only which is possible, tautomers are possible. I hope you got the clarity. Come on, let's go to the next question. Two possible stereoisomers for enantiomers, diastereomers, conformers, and rotomers. Rotomers and conformers, there should be a single bond, that is a rotational isomer, that comes under conformers. Actually, conformers and rotomers are same category only. So rotomers is nothing, conformational around a single bond, rotational isomers in a single bond. And conformers, it is actually same molecule that can be interconverted by rotational of the single bond. Right now here diastereomers actually minimum you should have what it is, two chiral center, it should be there, two chiral center, but here there is only one chiral center, it is there. Here double bond, it is there, it is actually what it is here, single bond, it is strictly rotational around each other. So it is 100% enantiomers only it is possible. I just to draw the structure for you to understand. So here hydrogen, here OH, and this side cyclohexane, right? Here double bond, here COOH, and this side hydrogen, right? So and the same way, because enantiomers is non-superimposable mirror image, right? So that means here the same, the side COOH, here hydrogen, here double bond, and this side cyclohexane which is connected with HOH, right? So HOH, right? So this is actually non-superimposable mirror image, only one chiral here, this side one chiral. So this is actually enantiomers. Enantiomers comes under non-superimposable mirror images. So 100% this is actually option A. Option B, diastereomers, minimum two chiral center has to be present here. Only one chiral is available, right? Only one chiral center, right? So only this is possible. Hope you got the clarity. Conformers and rotomers comes under single bond, right? That is actually, but here double bond it's coming, right? So this will not be applicable for these two answers, right? This also it will not be applicable. Why? Because minimum two chiral center has to be there. One will be fixed, the other one it will be changing. That is a spatial arrangement that is called diastereomers. Enantiomers, I hope you got very clear idea about non-superimposable mirror image, right? Come on, let's go to the next question. The next question, as we observe, the configuration of the carbon atom C2 and C3 in the following compound or respectively. So we have to identify RS configuration. So RS configuration, for that we should know that CIP rule. What about that CIP rule? Con, Ingold, Prelog. They have given that idea about what it is, how to identify RS configuration, that is absolute configuration, very easily with the trick. Okay, let me draw the structure for you first, then I can write that. So according to this, fourth priority and horizontal, fourth priority atomic number lower, it is fourth priority, atomic number higher, that is the first priority. So in that COOH, here H, here OH, and the same way here OH, here H, here CHO. Okay, now in that fourth priority is on horizontal clockwise. Clockwise means what? Anti-clockwise means what? So clockwise means it is R, and anti-clockwise means it is S. I hope you got the clarity. So clockwise means R and anti-clockwise means yes. Okay, now here according to that atomic number 1, so higher priority, this is 1, and of course this is 2, and this is 3, and this is fourth priority. So we can go like this only. So this is anti-clockwise. Anti-clockwise means it is yes. And the same way, the next one here, atomic number higher. So this is here priority 1. And of course, this is 2, and this is 3, and this is 4. So here, what to say? Like this is a clockwise. So clockwise means, this is clockwise means it is R. So this is yes and R according to that CIP rule. Fourth priority is there on horizontal. This is horizontal only, right? So according to that, yes and R. So which is the correct option? Option D is the correct option. So fourth priority is on horizontal. Clockwise means R, and on anti-clockwise means yes. I hope you got the clear idea about CIP, that is con, gold, and predlog, absolute configuration, RS configuration, how to identify. I hope you got the clarity. Come on, let's go to the next question. Chiral. So we have to observe which compound is having chiral. Chiral means 4 different groups or atoms attached to that carbon. So that is called chiral carbon, chiral compound, right? Okay, now in that point, option A, it has mentioned very clearly. So 3-methyl 3-hexene. So in this point, option A, 3-methyl 3-hexene. Hexene means 6. 1, 2, 3, 4, 5, 6. Right. So in that 1, 2, 3. So 3-methyl. So this is CH3 and hexene. So here 3-methyl 3-hexene. Right. So in that, okay, now this is actually, now let me draw a complete diagram. That means this is B, 4-chloro 1-methyl cyclohexane. So 4-chloro 1-methyl cyclohexane. So cyclohexane first let us draw. So here what it is? 4-chloro 1-methyl cyclohexane. Right. This is chloro. Hexane, not hexane, hexane. So 4-chloro 1-methyl cyclohexane. Then this is C, 2-phenyl pentane. 2-phenyl pentane. So how to draw the 2-phenyl pentane? So pentane, here phenyl, let me draw that first. And here, what to say? Here, which is attached with, here 2-phenyl pentane, right? 1, 2, 3, 4, 5. Okay, so that means here one hydrogen is there because the CH2, right? So 1, 2, 3, 4. 1, 2, 3, 4, 5. Right now, next one, fourth option D. Option D, 1, 3 diisopropyl benzene. 1, 3 diisopropyl benzene. Right. Okay. It's very clear. Benzene. This is benzene. Here, diiso, methyl, diisopropyl. Right. Right. So here CH3, here also CH3. So this is CH, right? Now here also 1, 1, 2, 3. Here also the same, right? So here also CH3, 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 CH3. Now in that we have to observe which compound is having chiral. Okay, do you think here there is a chiral? So this side C2H5, this side C2H5. It is actually what it is. Both the side, it has to be different. I mean, attachment should be different. But here actually it is this side sp2, but here sp3, right? Here also sp3. Right now here you cannot find a different group or atoms attached. So this is achiral. So this is not a chiral compound. Right now here also you cannot find any chiral. Actually it is no chiral. Chiral means 4 different groups or atoms should be available, right? So you cannot find any chiral over here. And the next one, see here in this point, here 1, 2, 3. So that means here C3H7 is there. Whereas this side CH3 it is there. This side hydrogen and this side what it is? Benzene. So this is actually chiral. I hope you got the clarity. 4 different groups. So this side C1, 2, 3, C3, H7. Okay, CH3, CH2, CH2. So 3, 4. So 7. C3, H7 is there. This side CH3 it is there. This side benzene is there. This side hydrogen. That's what purposely I have drawn this side. Okay, so that means here 4 different groups. So this is completely what it is. Chiral. So this is actually chiral compound. See, it is chiral. And let us check this point. And chiral means 4 different groups. But here similar group it is available. Methyl, methyl. This side also methyl, methyl. No. So that means here there is no, I mean, here actually what it is, achiral only you can find it is achiral. So you cannot find that chiral. Achiral only. Chiral means 4 different groups. So compound C is that chiral. Hope you got a clear idea. C is that chiral. C only 2-phenyl pentane is that chiral. I hope you got a clear idea about all these questions. 200 questions we have gone through level 1. I hope you got a very clear idea about isomers, and thank you for your great support and thank you for watching. And in our next video we will check aldehydes and ketones. Why? Because it is the second most important in that JE mains. See, you just go through thoroughly level 1 of organic chemistry and PYQ. If you go through thoroughly, definitely you will get the best marks in the JE exams. I hope you got that clear idea, and thank you for your great support, and thank you for watching. Whether chiral or achiral, you just observe on your own. But this picture says whenever we see the question or whenever we see the problem, all these questions will appear in your mind. What, when, where, how, why. All these questions will hit you to identify the analyzing, the way you are analyzing, you will get the correct answer. And you should have that clear concept. So if you know the concept thoroughly, number of times you have to do the practice correctly, correct questions, if you follow the correct keywords or correct concept ideas, so you will get that clear solution. And thank you for your great support.